A wait in NetLinks programming is, at its simplest, a delay in executing code. Why would you want to delay executing an action? There are many reasons. For example, let's say you have a projector and you want to switch to a specific input after it is warmed up. You would simply place a wait for the length of time it takes for the projector to warm up and then execute the input switch. There are three types of wait statements in NetLinks. First, timed waits. You wait for a specific amount of time and then the code executes. Second, conditional waits. You wait for a specific condition to be met, then the code executes. Third, timed conditional waits. This is similar to the conditional wait with an addition of a timeout feature. A timed wait is your basic wait. You wait for a specific amount of time and then the code executes. This tool is used by calling the keyword wait followed by the required time parameter. The wait time is always measured in tenths of a second. Technically, wait times can be used with a level of 10 milliseconds of precision. However, this feature is rarely used in real-world programming. The following graph explains how wait times are converted to seconds and milliseconds. So in the first example, wait 0.1, it equals out to 1/100th of a second, as well as 10 milliseconds. In the second example, wait 2, it equals out to 2/10ths of a second, as well as 200 milliseconds. And if you have a wait 30, it equals 3 seconds, as well as 3,000 milliseconds. This page shows you how a simple timed wait might be used. A conditional wait is a wait that is looking for a certain condition to be met, and if and when the condition becomes true, then the code executes. Use with caution. If the condition is never met, the associated code will never execute. A timed conditional wait is like a conditional wait in the way that it is looking for a certain condition to be present, but it does include a timeout feature. If the condition is not met and the time runs out, the code will not execute. The timeout feature allows for the wait to be destroyed after the timeout elapses. In the previous example, you will have noticed that the timed conditional wait has a name encapsulated in single quotes. Naming waits allows you to manipulate them like canceling, pausing, or restarting a wait request. An example of when manipulating a wait would be worthwhile would be to cancel system off macro when a room is going to continue being used after the scheduled time has elapsed. To name a wait, you would use ASCII string literals. String literals as a name means that single quotation marks are used, it is case sensitive, and naming conventions should follow the style guide including spaces. In addition to the three types of waits, there are two ways to establish how a series of waits are to be counted. The two styles of waits are stacked and nested. Stack waits are when all waits within an event start counting down at the same time. Nested waits are when the wait time is the sum of all enclosing waits. This is an example of a stacked wait. In this example, execution of code is completely dependent on how long each wait time is and not where it is located within this button event. Additionally, all of the waits are in the same hierarchy. The last event happens at time 50 seconds, relative to time 0, which is the time of the button press. Nested waits means that a wait is nested inside of another wait. The first wait will start counting, and when it finishes, the next wait will then start counting. In other words, the wait times are cumulative. I am going to use the same time values and devices from the previous example. In this example, the execution of code is completely dependent on the order of nesting and changes when each action is executed. Each wait will execute only after the previous one is finished counting and therefore will have a cumulative effect. So the total time of execution of all of these waits is different from the stacked waits example at 63 seconds. In the next tutorial, the implementations of weights, I will show you how to use weights in a real-world example.